This conference will now be recorded.
Hello everyone. Today also we will continue nomenclature of organic compounds. So here as you can see number 4. So previous 3 points we have already seen, and this is based on how to choose the longest chain, that is the parent chain. All these rules we are discussing under that heading. Now once this will be finished, next point will be how to select that is how to number the parent carbon chain. So first step will be you have to choose parent chain based on some rules that we are continuing. Number 4 we will start in today's class, and after that there will be the next point, which is how to number the parent chain. Okay, so this number 4th point, it is saying that the chain which is containing the main functional group, that must be selected as parent chain. So where the functional group is present, that must be chosen as the parent chain, even though it contains less number of carbons than any other chain without the main functional group. So it may be that in some cases you have already chosen the parent chain and this is the longest chain, but it is not containing the functional group. But there is another way you can choose the parent chain which is not longer, that is which is less longer than the previous way that you have chosen, but it is contained in the functional group. So you have to give priority to that. So here we will take one example to understand this point. Let me use black color. So the same molecule I will draw again. Because why I am drawing these 2 times? Because I will do that is I'll choose the parent chain in different way. So first time, suppose I am starting from this side, 1, 2, 3, 4, 5 and 6. Then another way I can choose, which is now from this side, that is this point, 1, 2, 3, 4. Sorry, there will be one more carbon like this. So now if I start the numbering from this position, number 1, 2, 3, 4, 5, 6, 7. Now in this case there is total 7 carbon atoms, but here in the previous one there is total 6 carbon atoms. But see, in the previous one, the longest chain, though it is containing 6 carbon, but it is containing the functional group OH. So that is why we have to give priority to this, but not the second one. So this is not correct way to choose the longest parent chain, because though it is 7 carbon, but remember it is not containing OH group. So the longest carbon chain, it should contain maximum number of carbons. That rule is obviously okay, but you also have to keep in mind it should also contain OH. So it is basically overcoming the other factor. Even if it is containing higher number of carbon, but still we are not choosing it because OH group is not present. Here OH group is as if treated as substituent, but that is not correct way. It must be present in the parent chain. Okay. So keeping all these factors in mind, now OH is the functional group, and here we have some substituents. So at 3 position there is substituents which is containing total 4 carbon. So 4 carbon substituents, and at 4 position we have one methyl substituents. So total 2 substituents are there. Now obviously as OH is functional group, we will end the name with all, right? But for these 2 substituents, there is methyl substituents and there is butyl substituents. But remember, it is not just simple butyl. Suppose if I am saying it is simple butyl, then it should start from like this. Then it should be starting like this. 1, 2, 3, 4. So total 4 carbon butyl. So it is normal butyl where it is attached with the main chain from the first carbon. But here it is basically attached with the second carbon. This is the second. So let me number it again. But it is not the numbering for the parent chain. I am doing this numbering just for to understand what is the attachment point with the main parent chain. So I am doing it with prime. 1 prime, 2 prime, 3 prime, 4 prime. So at 2 position it is connected with the main chain. So if we simply write butyl, it will not be correct. So 4 carbon substituents can be attached to main carbon chain in different way. It can be attached with the point 1, it can be attached with the point 2. Another way also it can be attached. Suppose this is the parent chain, whatever is present both sides, and here the 4 carbon chain is not chain, 4 carbon substituent is attached in this way. See, here it is the carbon and with 3 more carbon. So here also it is 4 carbon. This is also 4 carbon. This is also 4 carbon. But try to understand, all of them are different. So this is N-butyl, that is normal butyl, where it is connected with the first point. Here it is connected with the second point, and here it is connected completely different way. So this is basically tertiary butyl, and it is written in this way, TBUT. But we do not have tertiary butyl. We have this type of attachment where it is connected with the at point 2 prime. So how to name it? This will be the name. So see, 3-sec-butyl. Now this sec, as we have already mentioned in previous class, it is basically secondary because it is attached to it at the point 2. So it is sec and it is in italics. Then it is butyl, and whatever we have written, it will be within bracket. So whatever within bracket, that is at point 3, at number 3. After that there is 4-methyl. So B will be coming first because alphabetically B comes before M. So that is why B we have written first, butyl. And then it is 4-methyl. And as there is total 6 carbon, so here root word will be hex. And at 2 position there is functional group, so that is why hexane 2 all. And don't write this E, because if you are writing hexane in E, then it will be treated as if it is alkane. But as there is functional group, so you have to omit this E. Now sometimes it is also written like this, that is 2 is mentioned before hexanol, and here it is hexane then 2 all. So better you choose this one, because according to Ayub, this one is preferred. Though I am not saying this is wrong, but nowadays this one is preferred, hexane 2 all. And these two are basically substituent at 3 position and 4 position. Next we will start numbering of parent chain. Now we know all the rules based on which we can choose the parent chain or the chain that you will actually number. Now once you have already done that fact, next you have to understand how to number the parent chain, because parent chain number you can do in different ways, right? So the first point here we are discussing the positions of multiple bonds, that is CC double bond or triple bond, substituents, it may be chloro, nitro like this, then side chains, that is carbon side chain obviously, or functional group on the parent chain are to be indicated by locants. Locants is nothing but simply number 1, 2, 3, 4 by numbering the carbon atoms in the parent chain. Even though two different series of locants are possible by numbering the carbon chain from either side. So once you have chosen the longest chain like this, you can start numbering from this side, left hand side, or you can start from right hand side. Now when you will do so, you will see both will not give you the same position for all these multiple bond substituent side chains. So there will be some difference. Now how you will understand which one is correct, whether to do from this side or the other side? Either side, right? Now the correct series is chosen by following the rule of first point of difference. Now what is first point of difference? That we will see. Rule of first point of difference. When series of locants containing the same number of terms are compared term by term. Now what it means? Now look at this. Here in the first term we have 1, after that it is 2, then it is 2. But in the second one, 1, 1, 2. If you compare this one with the second one, first position in both cases it is 1. Now the second position you can see some difference. Now we will choose the second one because not the first one, because here after 1 we are getting lowest number. So this is the first point where we are getting some difference, and when we are getting difference we will choose that one which is having lesser number. So we will choose the blue one, not the red one. So when we series of locants containing same number of terms compared term by term. So it is not that you will compare these numbers as a whole, just term by term you have to compare. Then the series which contains lowest number on the occasion of first point of difference. So in this case, at second position you are having the difference, but it is not necessary. You can also have difference at the first point, or you can have difference at the third point. Whatever it is, whenever you are getting the difference, you have to stop at that point and you have to compare which one is least, and you will choose that one. Now we will take one example to understand this. Same molecule I will draw 2 times. So same molecule I am drawing 2 times because I will do the numbering from both sides. Suppose I am doing the numbering from this side. So it is 1, 2, 3, 4 and 5. Now there is another possibility I can do the numbering if I am starting it from this side. 1, 2, 3, 4, 5. Now in both cases it is 5 carbon. So based on that you cannot differentiate. Now what you will do, in the first case, just try to understand what are the different substituents, what are their number. So in first case you have methyl group at 2 position, then you have next methyl group at 4 position, at the same position you have another methyl group. So it will be 2, 4 and 4 for the 3 methyl groups. It may be any other groups also. Now if you consider the second one, the blue marking, now you have methyl, first methyl it is at 2 position, next methyl that is also at 2 position, and the third methyl or substituents, in this case it is methyl, that is why I am saying methyl, now it is 4. So what is the first point of difference? First position both cases 2, second position you are getting the difference, so that is why you will choose this one, you will not choose this one. Now one thing you have to take care, don't add all these numbers. Suppose if you are thinking that if I am adding all these numbers, then it will be 2 plus 4 6, 6 plus 4 10, and here it is 2 plus 2 4 and 4 plus 4 8. So if you are thinking it is 8, that is least, there is another rule sometimes mentioned which is called as least sum rule, but that is actually a special case of first point of difference rule. If you simply consider this least sum rule, then also you are getting this is as the correct answer, but you may not get always so. It sometimes matches with this rule of first point of difference, but it is not necessary you will always get that. One problem we will also discuss, then this point will be more clear. So don't add all these numbers. This is not correct way to choose how to number the parent chain. Just you have to write first the numbers for the substituents or any other multiple bonds, functional group, whatever it is present, and you have to compare one by one. So here at second position we are getting the difference 2 4 4, but 2 2 4. So that is why we will choose the second one. Okay, so here the name will be 2 2 4, and there is basically total 3 methyl groups, so it will be trimethyl, and it is simply alkane pent N. There is no that is ANE after pent, after root word. Okay, so this will be the name 2,2,4 trimethyl pentane, not 2,4,4 trimethyl pentane. Okay. Now sometimes it may happen in the event that you are getting there is no first point of difference. So what I am trying to say, suppose you have numbered it just like the previous method we have followed. First we have done it from the left hand side, then I have done it from the right hand side. Suppose you have done the same thing, and in both cases you are getting the same positions. Suppose both cases you are getting 2 to 4, 2 to 4. Then what you will do? So in the event that there is no first point of difference in the locant, substituents are then numbered based on alphabetization, giving the first substituent in the name the lowest possible locant number. Now, how to choose which will be the first substituent in the final IUPAC name? And for that, you have to consider alphabetical order. So suppose there is ethyl substituents and there is methyl substituents. Two different substituents are there. Obviously, in the final IUPAC name, you will keep ethyl first, right? And then you will keep methyl first. So what you will do, you will give this one the lowest possible locant number. So here we will see one particular example regarding this. Numbering here already done. As you can see, if you follow the red numbering, then you are getting the positions 3 and 6. Suppose when you are following the red number, you are getting positions 3 where one substituent is there, and at 6 position, just follow the red one. I'm talking about the red one. At 6 position also there is substituents. Now when you are doing the green one, then also at first position, just you have to move from this direction. In the red one, you have moved from this direction. Now follow the right hand side direction. First position 3, again at 3 position, though it is methyl, but still it is 3. What substituent present, that is not important. At first position, first position, that is 3 position, there is a substituent, so write 3 first, and then the second substituent, it is at 6. So both cases, there is no first point of difference. Now, how to choose? If both the substituents are same, there is no question of alphabetical order. Suppose both are methyl, so it doesn't matter from which side you are moving. But suppose the substituents are different. In that case, here we are giving preference to this red one, because just forget about 3 and 6. When you will actually write the IUPAC name, then you will obviously write ethyl first, then leave some gap, then methyl, and then octane. Now, if you are following the red one, the numbering will be 3 and 6. So, and if you follow the blue one, sorry, the green one, then ethyl will get number 6. So that is why we are cancelling this and we are accepting the red one. So this example, that is based on this second point, when you are not getting any first point of difference, but you have two different substituents. If substituents are similar, it is okay. There is no problem. But if substituents are not same, you have to follow this. Some more examples we will see, but before that, here we have a note, and it is saying sec butyl. Suppose you have these substituents, or you have tertiary butyl. Remember, it is sometimes also written in short like this, TBUT. So when you are having this type of substituents, it is a basic, these substituents are alphabetized under B. Why? Because of this butyl B, and that we have also done in the first example of today's class, right? But there are some exceptions. When it is isobutyl, suppose instead of writing sec butyl, you are writing isobutyl. Isobutyl is like this. Total 4 carbon, obviously, because it is butyl. 1, 2, 3, 4. So this is the connection point. So if it is attached with the main chain in this way, so this is basically isobutyl. So this one is isobutyl, and isopropyl is total 3 carbon, and this is the connection point. So if you are having isobutyl or propyl, they are not alphabetized under I. Sorry, they are alphabetized under I, not B or not P. So here B and P you should not focus. Whenever you are using isobutyl or isopropyl and you are considering the alphabetical order, you have to focus on I. But for sec butyl, tertiary butyl, you have to focus on B. Fine. So here we have some more examples. See, different ways we have written. First, consider this cyclic molecule. Here we have methyl substituents and we have ethyl substituents. Now, suppose if I am starting the position like this, that is 1, 2. Suppose I am moving this direction. I am moving this direction clockwise. 4, 5, 6. And there is another way I can move, which is anti-clockwise. Now it is 1, this is 2, this is 3, 4, 5, 6. Now obviously we will prefer, that is first point of difference, if we consider, it is 1 and then 6 if you follow the maroon one. But if you follow the green one, it is basically 1 and then 2. So this is the first point of difference. And when you compare 6 and 2, obviously you have to give priority to 1, 2. Now 1 you have cancelled, 1, 6. This is already cancelled. You have already chosen 1, 2. Now under 1, 2, you have two possibility. So is it that you are first considering 1 at ethyl and then 2 at methyl, or the reverse way? Now for that, follow the same thing that we have done for this first example. Remember, in the same slide, what you have done, we have considered 3 ethyl then 6 methyl. So here also we will do the same thing. Obviously ethyl is first, whether you consider 2 or 1, but this one we have cancelled. This is the correct way to write it. 1 you have to give before ethyl, because E alphabetically it is before methyl. Okay. Now the second example, here second one is not correct. This one is correct. 4-methyl pentan 2-ol, not 2-methyl pentan. Now if you are numbering from this side, suppose 1, 2, 3, 4, 5. In both cases it is 5 carbon. Another way you can number. Now the red one is correct, not the green one, because if you follow green, then all is getting 4 and this one is getting 2. And then in this case, 4 before methyl and this is 2. Now when you are moving according to green one, then it is 2 and then 4. And when you are moving according to red one, then also it is 2, 4. So there is no first point of difference, but still we are choosing this one, because here functional group you have to give priority, that should get the least number. Okay. So sometimes there is no first point of difference, and in that case you have to give priority. If functional group is present, obviously you have to give it least number. And if there are some substituent present like ethyl, methyl or propyl, then you have to move according to alphabetical order. Okay. Now, if you solve this problem, the confusion of least sum rule and first point of difference will be clear. So here 4 names are already given, and we have to choose the correct IUPAC name for this molecule. So what I will do, first I will start the numbering from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here the first substituents I am getting at 2 position, then the second substituent I am getting at 7 position, then the third substituent I am getting at 8 position, right? And if I am doing it in the reverse order, 9, 10. Here the first substituents I am getting at position 3, and then I am getting at position 4, right? Then the third one I am getting at position 9. So 3, 4, 9 and 2, 7, 8. Now what is the first point of difference? See, this is the first point of difference. Just at the first position, first term is different. So first term is different, and which one is least? 2, 7 is least. So this one is accepted, this one is rejected. Now if you simply follow the least sum rule, when you add 3 plus 4 plus 9, 16. When you add 2 plus 7 plus 8, it is 17. See, here 16, 17. 17 is larger than 16, but still we are choosing 278 trimethyl. That will be the correct one. Why? Because of based on first rule of first point of difference. So don't consider the least sum rule. That may give you correct result sometimes, but not always. So this problem is the proof that here, though it is 17, it is 16, but still we are choosing because of this first point of difference. So correct answer will be 278, total 3 methyl substituents. Follow the first numbering, that is this dark blue numbering, 278 trimethyl, and here total number of carbon is 10, and for 10 we use dec, and there will be N because it is alkane. Okay, 278 trimethyl decane. The third one is the correct answer. The next rule, if two or more groups are not at equivalent positions, the group that comes first alphabetically may not have lower number. Now, in the previous case, what we have seen, there is no first point of difference. That is the last 2 to 3 examples that we have seen. I'm talking about this one. So here, if you follow the first example, 3-ethyl, 6-methyl, 6-ethyl, 3-methyl. So in both cases, it is 3-6-3-6. So there is no first point of difference. But sometimes it may have that they are not coming at same position. That means there will be some first point of difference. And when you are following that first point of difference, it may be that the alphabetical order, suppose ethyl is coming before methyl, but still it is not getting the lowest number, because after all you have to give preference to the rule of first point of difference. In the previous example, there is no first point of difference, so that is why we have given preference to the alphabetical order, or we have given preference if there is functional group. But if there is first point of difference, you can apply, that is, the condition is such, you can apply this rule. Obviously, then you have to follow this rule. So here, if we see this example, we will see a molecule. And the same molecule I will also draw once more. So I will draw the numbering 1, 2, 3, 4, 5, 6, 7. And in the second case, I am starting the numbering here. 3, 4, 5, 6, 7. So in the first case, I am getting substituents at position 2 first, and then the second substituents at position 5. Now when I have followed the second numbering, the first I am getting at position 3, and the second substituents I am getting at position 6. So here they are not present at equivalent position, and you are getting the first position, first term we are getting based on rule of first point of difference. 2 and 3 are not same, and you have to give preference to 2, 5 because 2 is lesser than 3. So this one will be correct. Now when you are following this, there is ethyl substituents, there is methyl substituents. Obviously, you will write ethyl first, and then you will write methyl. Total number of carbon 7, and there is no double bond, so it is simply heptane. Now, what about the position? Ethyl you will always write first, whatever is the position of ethyl, because based on alphabetical. But when you will put number, now it is 5 ethyl, because we have followed this numbering and ethyl is at 5 position. So it is 5 ethyl and then 2 methyl. But if you follow the second one, it will be 3 ethyl and 6 methyl, but that is not correct. So I will not write that name because this one is correct. So 5 ethyl 2 methyl heptane. Just put ethyl first, methyl second based on alphabetical order. But when you will put the number, as we have followed first point of difference rule, so this one may not get the lowest number. That is mentioned in this rule. May not have the lower number. So ethyl is getting 5. Methyl, though it is after ethyl, but still it is getting the lower number. Okay, because we have followed first point of difference rule. The multiple bonds, if present, they have, that is CC double bond or triple bond, they have higher priority over any alkyl group, that is R group, carbon hydrogen, halo, nitro group. Halo means Cl, Br, I. or alkoxy, that is OR. It may be OMe, it may be OET. So you have to give preference multiple bonds when you will choose the priority. And they should be given lower number. Now here we will see one example. Now here I am doing the numbering, suppose from this side 1, 2, 3, 4, 5, 6 and 7. But if I am doing the reverse order, so the first one, that is if we follow the black numbering, then the double bond is getting position 3 and here methyl group is getting 6. But the other numbering, that is the purple one, now 2 and 4. In the previous case it is 3 and 6, but now we are getting 2 and 4. But here you have to choose 3 and 6 because in the second case double bond is getting number 4, which is not correct. In the first case, that is black numbering, double bond is getting number 3. So that is why we have to choose this. Here don't consider this first point of difference rule. Fine. So what we will write, as we are following the black numbering, so it will be root word hept, 3 position there is in, and we have prefix, that is 6 position there is methyl group, so 6 methyl. 6 methyl there is no gap, then hept, then 3 in. So we are getting double bond, we are getting number 3 to the double bond. Fine. If CC double bond and triple bonds are present at equivalent position. So until now we have seen double bond or triple bond, they are present, either double bond is present or triple bond. Suppose both these types are present, that is CC double bond is present, triple bond is also present. And how they are present? Both are present at equivalent position on the parent chain. Equivalent position means whatever side you are starting numbering, in both cases double bond is getting and triple bond is getting same number, and that is the meaning of they are getting equivalent position. So CC, in that case you have to give CC double bond lower number. But if they are not present at equivalent position, now position should be decided based on this. Obviously without example we will not be able to understand. So here we will take example. Triple bond. So this is the molecule where you will see if you are moving from left hand side, double bond is getting number 2. If you are moving from the right hand side, then also this triple bond is getting number 2. That means they are present, that is CC double bond, CC triple bond, they are present at equivalent positions, right? But suppose I am drawing another molecule. Now in this case, look at the position of double bond when you are moving from left hand side. It is basically 3. But when you are moving from right hand side, the triple bond is getting position 2. That means now they are not equivalent positions. So first, whenever you are getting double and triple bond simultaneously, you just have to check the fact whether they are present at equivalent position or not, because based on that, numbering will be different. So first you will see when they are present at equivalent position, then CC double bond should be given less number. Okay. So see here what we are doing. we will start from, that is this numbering we will focus, because we have to give it list number. Here we do not have any substituent, so no question of prefix. Simply start from the root word, heft. Total number of carbon 7. After heft, 2 in, and for double bond, which is at 5 position, right? This position, as you are moving from left hand side, so at 5 position, triple bond is starting 5 ein. Okay, so this will be the correct name when they are present at equivalent position. But for the second molecule, now you have to consider first point of difference. See, if you are following the moving from left hand side, the first position you are getting at 3 left. If you are moving from right hand side, the first position where you are getting the unsaturation, it is at 2 when you are moving right. So this is the first point of difference. So that is why we will cancel this one. We will accept this one. So numbering will be started from this side. Again, you will start with heft because we do not have any substituents. In, it is always before y because alphabetically E comes before Y. So whatever is the position of double or triple bond, it will always be written alphabetically first. So 4 in, 2 in. Why 4 in? Because double bond is starting at position 4. So CC double bond triple bond both are present simultaneously. First you have to check whether their positions are equivalent or not. If it is equivalent, give priority to CC double bond. That means you have to give it list number. But if they are not at equivalent position, simply follow first point of difference. Right? Now we will see if there is functional group present, it is always having the least number even though it violates the first point of difference rule. So this functional group, we are giving it so much priority that even if you violate this, it is okay. So it has even more priority over multiple bonds. Fine. So we will draw a molecule where double bonds and some functional group both will be present so that we can compare. So the same molecule I will draw again. Now in the first case, suppose I am starting from this side. 1, 2, 3, 4, 5, 6, 7, 8. And second one, I am starting from this side. So in both cases it is 8. That is okay. But if you consider the positions, that is in the first case, at 4 position we are getting a a functional group. Then at 6 position there is methyl, and then at 7 position double bond is starting. So we will write the terms. But for the second one, number 1 there is double bond, then at 3 there is methyl substituents, and then 5 there is OH. Now if you simply follow first point of difference, you will accept 1, 3, 5, not 4, 6, 7. But this is cancelled. Why this is cancelled? Because in this case, OH is getting 5. In the previous case, it is getting 4. So that is why this will be accepted. And if we write the name, then total 8 carbon. That means oct. That will be our root word. And after oct, as at 7 position there is double bond, so it is 7 in, 4 all. And we have substituents, that is prefix we have to use, which is at 6 position. 6 methyl. 6 methyl, do not give any gap. Directly write oct and then hyphen 7 in because of the double bond. And at 4 position we have our functional group. So 6-methyl oct, 7-in-4-ol. Okay. Second one not accepted, though here first point of difference is preferred, but we are violating this just to give priority to the functional group. Now some examples we will see. So this molecule, in one of the previous classes we have already discussed it, where we can apply primary prefix, which is cyclo, because it is cyclic molecule, and primary prefix, which is also known as infix. This type of term we use, that is applicable only for cyclic compounds. And here after that we have secondary prefix, which is 4-chloro, that is the substituents. Total number of carbon 6. Then it is alkane because there is no unsaturation. And here the secondary suffix CO2H. But see, in the main chain, that is the cyclic chain, this, though it is at one position, but numbering is not started from CO2H. So it is not part of the parent chain. And we already know in the previous one of the previous classes we have seen this rule. When the suffix it is not, that is the main functional group, it is not part of the main chain. That is whether it is cyclic or not. Whether it is cyclic or not, if it is not part of the main chain, that is if it is not part of the positions, because I have not started the numbering from CO2H carbon. So that is why it will be carboxylic acid, not oic acid. If you are writing oic acid, it is wrong. Now finally the name is 4-chlorocyclohexane 1-carboxylic acid. You don't have to remove E for this in this case. Simply write it like this. At one position you have to mention the carboxylic acid. Come to the second one. It is simply carbon and hydrogen. We do not have any functional group. So numbering, how to start? 1, 2, 3, 4, 5, 6, 7, 8, and then we have 9. So total number of carbon in the parent chain, it is 9. Now at 6 position we have isopropyl group. At 3 position we have ethyl, isopropyl, ethyl, and at 8 position, 2 position we have methyl. Ethyl at 4, 1, 2, okay, and 6 position there is isopropyl. Now why I have started the numbering from this side, if you see 1, 2, the positions for the substituents, if when you are moving from right hand side numbering, it is 2, then 3, then 6 and 8. 2, 3, 6, 8. But if you are moving from the left hand side, then the positions will be 2, 2, 3, 4. So see, this is the first point of difference. That is the second term, that is the difference. So that is why we are choosing this one, 2, 3, 6, 8. So if the question arising in your mind, why I am numbering from the right hand side, then this is the answer based on first point of difference, right? You can also try it yourself. Now if we follow this, in the final name you have to write ethyl first, because E comes before I or M, and then I for isopropyl and M for methyl. Remember, when it is isopropyl, I should be considered as the alphabet, because if you're simply following P, then it should not be before methyl, MNOP, P be after M, but we are giving priority to I. So that is why ethyl is written first, 3 ethyl, 6 isopropyl, whatever is the position, alphabetical order should be made. And methyl groups, 2 methyl groups at 2 position and at 8 position. So 2,8 dimethyl nonene, because there is total 9 carbons. So here word root non, we do not have any primary prefix because it is not cyclic, but we have secondary prefix which is for substituents. There is no functional group, and this is the final name. Come to the third molecule. Here we have double bond and triple bond, both in the same molecule. If you are moving from left hand side, this position double bond is starting, which is position 2. If you are moving from right hand side, triple bond is getting position 2. So they are basically at equivalent position. And which one you have to give priority? You have to give priority to CC double bond. So that is why we will start numbering from this side. Total 6 hex. Nitro is the substituent. So it is at 2 position 2 nitro. And as here we have given preference to that is double bond. So that is why primary suffix should be normally primary suffix. What we will do? We choose whether there is saturation or unsaturation. So if it is saturated, it is N, and if it is unsaturated, it is either in or I. But we have both type of unsaturation. But we are as giving priority to double bond. Their positions are equivalent, so that is why 2in is the primary suffix. This one will be the secondary suffix. Now come to the final name, hex. That is the root word. Prefix is 2 nitro. After hex, it is 2in 4-ine. So in should be written before ine because E alphabetically comes before Y. Now the next molecules are very interesting. Y, C. I am writing this molecule COOH. It is very small size. Basically here we have one mistake. There will be one more CO2H. So this molecule is actually drawn in the table. Now here interesting thing is when we will choose the main chain, it is like this 1, 2, 3. So we have not considered any of this carbon. This is basically if I go into details, that will not be possible because when you will separately study carboxylic group compounds, there will be a specific rules for a specific type of compound. Suppose you are studying alcohol, so there are some specific rules. You are studying carboxylic acid, there will be some specific rules. So you are not going into the details of that. You are in general way we are discussing the IUPAC nomenclature. Okay. So here as this example is very interesting. Here the carbon of CO2H is not considered. We have considered the parent chain, and as if these three are substituents. And that is why as these three CO2H, they are not part of the parent chain, we have not used oic acid. Oic acid is not used. That is used when CO2H is part of the numbering. Here that is not the case. So that is why prop is the word root, N is the primary suffix because we do not have unsaturation, CC double or triple bond. And here in the functional group, just like the first example, remember we have used the term carboxylic acid. Here also the same thing, propane 1, 2, 3 tricarboxylic acid. Now if you compare this molecule with the second one, only difference is here we have one carbon extra. That is the difference. Now in this case, the numbering is paired. That means 5 carbon. So it will be now like this: 1, 2, 3, 4 and 5. And as if this group is considered as substituent. Now it is not simply CO2H, it is CH2CO2H. And this is called carboxymethyl because methyl means what? Methyl means CH3. But suppose one of the hydrogen of methyl, if you replace with CO2H, then the name is carboxymethyl as if it is derivative of methyl. And at 3 position you have carboxymethyl. So that is why as a whole this is our substituent. Just like 2 nitro, we will now say 3 carboxymethyl within bracket. And in the parent chain there is total 5 carbon considering the 2 CO2H, and that is why we are using dioic acid 2 times. Dioic acid, we are not using carboxylic acid, right? It is N. Now come to the name penta, that is a root word. Actually it is not penta, it is continuing. It is pentane dioic acid. Fine. And the prefix is 3-carboxymethyl, carboxymethyl within bracket. So 3-carboxymethyl is the prefix, then word root, pent, and followed by N, pentane, and diuic acid. The last one, if it is not visible properly, let me draw it. So there is a CHO group and amide, CHO and CONH2. Now here we have to give preference to CONH2, and how to choose preference, that we have already discussed. So among these two groups, as we are giving preference to this one carbon I have missed. Numbering will start from here. So in the longest chain there is total 5 carbon, and at 5 position there is oxo group. Oxo means 5 oxo means simply C double bond O. Fine. And CONH2 we are giving priority, so that is why it will end with amide. Amide is the main functional group. Total number of carbon, word root pent, it is N because we do not have CC double or CC triple bond. Pent N, but it will start with the prefix 5 oxo, then pentane. But as it is starting with vowel, so this E will be omitted. Pen, TAN, then simply amide. Okay. So these are some of the examples where we have applied all these 2 types of prefix, 2 types of suffix, word root, and then the final name. Now here we have a problem. The compound which has one isopropyl group. So here you have total 4 names given. All are ending with pent. So obviously you have to draw all these molecules 4 times, you have to draw, so that you can find whether there is any isopropyl group present or not. Isopropyl group means Me2CH group, and then there is the connection point, or you can write it like this. This is the connection point. So propyl, 3 carbon, but isopropyl. So this is isopropyl group. Now let me draw the first molecule A, 2233 tetramethyl pentane. So whenever it is ending with pentane, simply write the chain first. Now suppose this is position 2, this is 3. At 2 position 2 methyl group, 3 position 2 methyl. But in this molecule you do not have isopropyl group. Then the second molecule, again pentane. Now this is the middle 3rd carbon, and here you have 2 methyl group, but here you do not have any group like isopropyl. Then come to the 3rd one, again pentane. 2 position, 3 position, 2 position 2 methyl, 3 position 1 methyl. Is there any isopropyl? No. The last one, only 2 position there is methyl. Now we have the isopropyl group. This is the isopropyl group, Me2CH, which is connected with this carbon. So that is why last option will be the correct option. Okay. So we'll end with this problem. IUPAC name of neopentane. Now what is neopentane? This is something new we are discussing. So pentane, obviously it is 5 carbon. But what about neo? So the neo term is basically when you have this type of tertiary butyl group, that is 3 methyl group attached to 1 carbon. When you have this type of moiety present, but obviously total number of carbon has to be 5. But when you have this type of group, then it is neo. So how I will write it? 3 methyl group when you place. Already 4 carbon done. Only 1 position is there. Where 1 more methyl. Now, when you will number it, you have to number it, then only you can get the IUPAC name. Numbering, this is equivalent type of structure. So numbering you can start from any position. 1, 2, 3. This is the longest chain. And at 2 position you have 2 methyl groups. That means the name should be 2,2-dimethyl propane. And that you can get in option B. 2,2-dimethyl propane. It is not ending with butane. This is also propane. But see, even if you count the total carbon, it is 5 carbon and propane means 3. And in 2 position, 2 methyl means total 2 plus 3 it is 5, right? So 2,2-dimethyl propane, and I can also draw the same molecule like a plus sign. It is a one-line structure, and it looks interesting, right? This is the middle carbon, and these 4 are basically all the methyl groups. And remember this group, when you simply consider this Me3C group, suppose we have OH, so this is basically known as tertiary butanol, TBuOH. You can also write it TERT butanol. Okay, so it is, in short, it is written as TBuOH. TBu means this group. If I am saying TBu amine NH2, then it will be Me3C NH2. So remember this group, when it is only 4 carbon, and if it is like this, that is with a single carbon, 3 methyl substituents are there, it is tertiary butyl group. But when I'm saying neopentane, this group that is attached to one more carbon, then you can call it neopentane. Okay, so we'll end the session here. Some more problems we'll see regarding IUPAC in the next class. Thank you for listening.